Okay, good morning. In the previous session, we discussed about the what is a variable, how can you define the variable, and then what are the different variables, the declaration of variable, how can you perform your some function like that. Now we are going to know about the some of the topics related to the variable. That means what is the correct way writing the variable here? What are the different way for writing the variable? What is the correct way for writing the variable? And then the sum of the integer and floating point number. You will discuss about the integer and floating point number related information. Okay, how can you write a correct way of variables here? You have a some description is there. Here, names of the variables are in lowercase letter. That means maximum time. That means you may use the uppercase letter. That means for the maximum, you will use a names of the variable lowercase here. For example, let us take a simple example for writing a simple variable here. Already you wrote some variable. For example, x is a lowercase letter, pi is a lowercase letter, and then some of the letters are there. Yes, name, student name is a lowercase letter. Here in this case, student name is a lowercase letter, and then anything here you will write the name of the variables always in a lowercase letter. The second important point in this case here is a, that means the word separation can be indicated by the underscore. Here if you having the length of the word is very long, here for example, if length of the word, that means if you want to introduce a word size some correct way, for example, new underscore sales in the year 2020 equal to 30 lakhs. Here, this is the size of the word here. If the size of the word is long, then you will use a center. Here, you will use a underscore sign. That indicates that the second point here in this case indicates that the word size is some long here that can be indicated by the underscore here. That is a way. And the names of types and modules begin with the capital letter, and word separation is shown with the upper camel case instead of underscore here. Here the type, that means names of types and modules here, always modules with the capital letter. Some, for example, function module, if you want to write a module here, some rama module, m is a capital letter here. Here that means the variable here, the module name always indicated by the uppercase letter. Here, the name of the function and macros are lowercase. If you want to write a function name, here the function name and then macro name lowercase letter without underscore. That means for the function name, you cannot use the underscore here. And then function that write to their argument have name that end in. This is a something you are representing the correct way of representing the variable. Here sometimes if you want to write the variable like this, here this is a correct way here. For example, sales at the rate equal to 3000. Here it's not a correct way for writing the variables. Here it's not executing. Here it gives some error message. It gives always some error message. The syntax, the token in this case after the end of the expression, here that is this is a not a correct way for representing the variable names here. And then another important thing here is the variable names, or some of the other way not defining the variable names here. Here one of the other way here, for example, you will define the variable. That means you will use some pi. Previously discussed about the pi, you can use the variable name. Some, for example, else in the sense it gives us some, it's not used. For example, else equal to false. For example, it's not a way representing the else equal to false. Here you cannot use the variable names like this. Here why are not variable names in this way? Here why? Because the variables in this case here that means the Julia cannot allows the disallows names of for the variables are the names built-in statements. Why? Because the built-in statement here. Here the built-in statements are there. You cannot use the built-in statement as a name of the variable. Here else, for example, try equal to 20. Here, how can you know the built-in variables here? The built-in variables, green letters. That means it appears as a green letters here. In a block of the statements, you are using the this type of built-in names. In this way, you will representing the names of the variables here. Here, another important one here is the operator precedence. The precedence in related information. Here, for example, operator precedence. How can you represent the precedence value here? Here the precedence value here. How can you represent the precedence of the operator? Here, what is the way? For example, if you want to execute the program like this, here for example, 5 plus 3 minus, for example, 5 plus 3 minus, here 8 divided by 2, into three. Here, how can you execute this one here? Which operator execute first and which operator execute next here? Here, you don't know about that value here. What is the result here? It gives some result here. Here, for example, it takes some time here. It gives some result like this, minus 4.0. It gives floating point number here. How can you get the floating point number here? First, which operator will takes here? Here, this will turned as a, here this value can be converted on the mission itself as a 5. That means open bracket here, 5 plus 3, and then minus, it's a converted into 8 divided by 8 divided 8 divided by 2, into, that means this is a one more bracket here, 8 divided by 2 into, that means it's converted here. Here, what is the value? 5 plus 2, 5 plus 3, 8, and then 8 by 4 into, that means the value here. This is converted like this here. Here, that means the system automatically converting this value like this. Here, first calculate the 8 divided by 2, that's value 4. 4 into 3, that's value 12. 8, if 3 plus 5 plus 3, the first is 3 plus 3, that means that's value 8. 8 minus 12, that's value gives a 4 here. Here, how can you execute this information? How can you get this 4 here? Here, you are getting this 4 based on a precedence values of a operator. The precedence value, how can you measure the precedence value here? In this case, here you can get the precedence values here based on a, that means the highest precedence value. Here, the bracket having the highest precedence compared to the operator here. Here, I am using the bracket here. For example, instead here, if you use the bracket here, that gives a different result here. For example, for this one, what is the result? In the sense, it gives us some 2 point. Previously, its value 4. That means first it will calculate the bracket value. After that, calculate the whatever made the operation here. First, precedence value here is a bracket here, and then this value, this particular value, division operator, and then a multiplication operator here. After that, that means the division operator, the first, after that division operator, that means division operator, multiplication operator, both have the similar precedence value. After that, plus, after that it takes a minus value. This is a precedence of the operator. This means in this way you will perform the precedence value based on the this information. For example, 2 divided by 3, minus 6 into 5. 6 into 6. Here, how can you calculate this one here? Here, the value here in this case here, you are calculating like this. Here, how can you calculate the value here? Here, this value here consider as a 5 into 2, 6 into 6. Here, the 2 into 5, 10, minus 6 into 6, 36. The value here is a minus 26, but I am writing the bracket here. First preference I am giving the bracket here. Here I am writing the bracket here. That means 2 into 5 minus 6 into 6. What is the value here? 2 into 5 minus 6. First it will calculate the bracket value, but within a bracket you have some value, some calculation is there. It will complete that calculation part. Here 5, here 5 minus 6 minus 1 here into that means based on the associative value also. Here not only precedence, here associativity in the sense associative, the associative in the sense first left to right or right to left, the plus and the left associativity, and then some of the unary operator have the right associativity. Here based on the precedence and associativity you are calculating the value. Here this having the left associativity, that's why it will calculate 2 into minus 1 minus 2 into 6, that's value equal to 12 minus 12, that's we say value like at minus 12. Here the based on the precedence as well as that means associativity, it will come later here. That means simple mathematical calculation, you are taking the precedence value only here. Okay, next important topic here is a integer and floating point numbers. What are the types of integers? And then how can you write a floating point number here? What are the different ways of writing the integer values here? Here, integers and floating point numbers are there. Here, the following are the Julia primitive number types here. Here, what are the primitive number types here? We have a the integer primitive numbers types are there for the in Julia. The Julia int 8. That means number of bits here is a 8-bit. If it is a 8-bit computer, it takes a int 8. Here the smallest value minus 2 power 7 to 2 power 7 minus 1. 2 power 7. What is the 2 power 7 value? The 2 power 5 32. The 2 power 6 64. 2 power 7 128. That means it's 128 minus 128 to 127. Here the values you are considering as the highest value 127, the largest value in this case int 8, and then integer value u int unsigned integer, that's value same. That means smallest value here you consider as a number of bits 8, smallest value 0, and then integer 16. That means I am using the 16 4-bit computer, that's why the values here minus 2 power 64, the minus value 2 power 64 to 2 power 63 minus 1, 2 power 63, that's why I am using the 64-bit computer. That's why for example unsigned integer value, it comes from 0 to 2 power 64 plus 1, and then comes to the into 128, unsigned integer 128. Up to this you have a different integer and floating point numbers are there. Here these integer and floating point number you will execute it in your program here. That means if you want to for example if you want to type the execution process here, for example already I explained somewhere, for example x equal to 25, here execute this one. Here how can you calculate this particular x value here? Here how can you calculate this x value? The value of x here, what is the value of x here? That means the type here I am taking the type of x. The type of x here is a, execute this one, the type of x is a int 64. Here this values, that means why, because why it is giving 64 here, our system is a 64-bit computer, that means the type of the value here I am considering as a 64-bit computer. Similarly the floating point number here, the floating point types here, For example, different floating point types are there. Here, what are the different floating point? Float 16, that means half precision, and then number of bits here 16. Floats 32, that is, and then float 64. The precision value here is a 30, 64. Here, in this way, you are taking the float values here. The next important one here is a literal integers are represented in a standard manner. Here, how can you represent the literal integers here? For example, if you take the integer values here, the literal integers here. Here, how can you take the literal integer in this case? Here, the letter, for example, 1 is an integer, 2 1 2 3 is a integer. That means in this way you will representing the literal integer value here. Here the values of the literal integer, that means for example it is a 1, this is a literal integer value, and then 1 2 3 4. Here take a 1 2 3 4, 1 2 3 4, it is also a literal integer value. That means in this case here you will represent the literal integers. Here the second important one is a default type of integer. The default type of integer literal depends upon a whether the target system has a 32-bit architecture or 64-bit architecture here. Here that means already explained the type here. For example, the type of the one, what is the type of the one value here? The type of the one, how can you calculate the type of the one value? Here if you take the type here, for example the type of the one, the type, what is the type of the one? That means 64-bit here. That is a representation. Here, another important third point in this case here is a, here the Julia internal variable sys word size. That means if you want to represent the word size indicates whether, that means the system size. There is a function, there is a, that means Julia internal variable, the variable name here, sys word size. Sys word size indicates whether the target system is 32-bit or 64-bit here. That means if you want to know about the our system size, here you will use a this variable. Here the variable is a, for example you will use this variable. What is the variable? Sys word size. Sys word size representing the size of the system. The sys word size variable here used to representing the size of the system. Here comes to the another important point. Here is a unsigned integers. That means unsigned integer here representing the unsigned info. If you take the unsigned integer values here, the Julia also defines the int and here here Julia defines a the types int and use int, which are alias for the system signed, and uint in the sense it's a starting from zero value, alias for the system signed and unsigned negative integer respectively. Here, for example, if you want to know about the integer value in this case here, for example, int. Here, if you take the int value, that means I am writing the int here. Here, I am writing the int here. Here, what is the int value here? That means let's use a 64 int 64, and then uint. Here, let's use a, that means uint value 64. Here, in this way, you are having the different integer values here. Here, another important point in this case here is a larger integer literals. Here you have a larger integer literals here. For example, in this case here, that means 32-bit or 64-bit systems here, large integer literal that cannot be represented using only 32-bit but can be represented in 64-bit. Always create 64 integer. For example, here for example they have a letter like this 64-bit letter. Here I am representing the 64-bit letter in this way. That means you are taking the more value here. Here, if you execute this one, its have values are 64. Here, another important point in this case here is a here unsigned integers are input and output. Here integer and output here. We have a integer value and then output value here. Unsigned integer input and output using a zero int prefix. Here I am using the zero int prefix and hexadecimal. Here you are using the hexadecimal here. For example, let us take it is a unsigned integers 0 int some value. Here how can you represent the 0 int value here? Here it is a way representing the 0 int. Here if you execute this one, this is called here unsigned integer value. Here some another unsigned integer value here is a the type of the answer in this case. For example, if you take the unsigned integers, here some of the capitalized by a, f and so on. Here execute this one unsigned integer 8, and then another important one here is a 0 into 128. Here what is the value for the 0 into 128? Here if you take this one, after executing this one, its value here 0 into these are all unsigned integer values here. For example, the type of the answer in this case here previously type of the answer here is a here 8 bits here. If the type of the answer in this case 16 bits here, that means 0 into 128 unsigned integer. Here for example, if you take the more example here more than that number. Here I am taking the more than that number. For example, 0 into 1 2 3 4 5 6 7, like that I am taking some values here. 0 into 1 2 3 4 5 6 7. Here what is the value here in this case? Here the value here is a here if you take the answer type. Here what is the answer type for this one? If you take a copy this one, here what is an answer type here it's maybe 32 bit. That means the type here the answer type unsigned integer with the 32 bits 16 bit. And then for example, long integer value I am taking here. For example, I am taking the long integer value here. Here at the time I am taking the long integer. Here I am taking the 0 into 1 2 3 4 5 and then hexadecimal format of value. That's the result here. That means what is the type of the answer in this case here? Here the type of the answer in this case here is a it's maybe a unsigned integer 64 bit. Like that the values you may change here the type of the answer that in this way. Here that is a the representation here that means the you are prefixing with the 0 into base 16. Here the binary and octal literals are also supported. Here in this case you will take the binary and octal literals. Here for example 1011, like that. Here a binary, for example, if I take the binary number. Here binary number, how can you represent the binary number here how can you represent the binary in this case? If you take the binary literal here the value binary literal here 0 into 3. Here 1 0 0 b 1 0, that is called here binary number. The binary number 0 into this value. That means in this way the constant literal values are represented. Here another important, I'll take another example here. The type of the answer here is a another important binary number, octal number 0 into here. How can you consider the octal number here? Here for example 0 O into 1 0 1 0, what is the value of octal number here? 0 to 7 8 is a 8 a, um, 8 again comes to 0, 9 1 10 2. The value here you consider it as a 2. Here that's value 8, octal number 10 10 here represented as a 8. It's maybe this may be the conversion for the octal number value. Here, for example, another way representation of the octal number here. Here, for example, different hexa number. In this way, you will represent the octal number as well as the hexa number. The binary and octal hexa decimal maybe. Another important point here is a the binary octal. The binary octal here, the binary octal hexaliterals may be signed by the minus immediately preceding unsigned literal. Immediately preceding. Let us take simple example. Unsigned signed by the minus and then immediately taking the literal. The value you are calculating that value also. For example, minus sign value it gives some 0 minus sign and minus 0 into 2 it gives a some value of here hexadecimal value we are considering and then 0.0002 minus here for the 0 that means it's converted into hexadecimal value and then representing the 0 here. Here in this way you will representing the octal decimal value. Here another important one here is a the maximum, the minimum and maximum representable values, the minimum and maximum representable values of primitive numeric types such as integers are given by the type minimum type maximum function. Here you are taking the minimum maximum function. That means the if you want to know about the values here, let us take a simple example. The type of minimum value, the type what is the type of minimum, type of maximum. How can you use the type of minimum and type of maximum in this case? For example, type of minimum integer 32-bit, type of maximum integer 32-bit. What is the result here? The type of the values here. For example, this value I think um, uh, minus uh, 214 crores 74 lakhs 83,600. That means in this way you have, if you take the type of the values 32-bit here, for example, type of the values are 64-bit. Here 64-bit the minimum value. If you want to know about the minimum value, if you want to know about the maximum value, here that's maybe a long values. Excuse the for the minimum and maximum. Here the type of the values here you are considering. Here another important point here in this case here for the numeric numbers, the overflow behavior. Here the overflow behavior in the Julia exceeding the maximum responsible value of a given type result in a wrapping behavior, overflow behavior. That means, for example, um, the for example, the value here consider here. Let us take a simple example here. Consider the simple example here. Here, if you consider this one, this maximum value, type maximum value here. Here, this number. The you may take this number. Here, if you want to write a more than that number here. Here, x plus 1. Here, for example, x value. Here, if you take the x having the some type of the maximum value. Here if you take the x plus 1, here what it gives here x and the type of the maximum, the maximum number here that value, the maximum for the 64-bit maximum value, that value here more than that value, that indicates the negative impression here, the negative value here. That means after that value, that is a representation. And then for example x, for example that indicates the maximum value here. For example, let us take a simple example here. Here for example x plus 1 equal to, that means either true or false here, type of the minimum. Here the x plus 1, the next indicates an value here, call it as a minimum, the minimum value, the lowest value. For the lowest value 1 minus 1 maximum value, minus 2 next minimum value, minus 3 next minimum, and then the lowest value. Here equal to either true or false. Yes, it is a true. Why? Because the highest minimum value, is this value for the 64. Here similarly you will calculate for the 8 bits of data here. For example, the integer value here and I'm considering here is a 8 bits of data. Yeah, for example, if you take the 8 bits here, you can easily this is the 8 bits data 127. Here I am taking the x plus 1 value. Here what is the result here? 128. Why? Because our system 64 bit system, 64 bits system, it will allows the x plus 1 127, the allows x plus 1. If it is a 8 bit system, it gives a value here is a 128 minus 128. Is it clear or not? Here if it is the minimum, why? Because it gives output like this, in the sense 128. Previously output here is a minus value. Here is a this value. Here in why here our system is a 120 64 bit system. I am writing the integer 8. That's why next integer value here is a 128. This is a, in this way you are representing the integer values here. And then another important one here is a floating point numbers. Here if it comes to the floating point number, in this way similar thing here for division. Here which type of numbers are floating point number? Here literal floating point numbers are represented in the standard format here. E notation when necessary. Here 1.0 1.2, here minus 1.2. For example, here if you take the, here the simple information, the floating point number, simple information for the floating point number here is it. Here the simple information for the floating point number. What is the floating simple information for the floating point number? Here I am taking this one. Here for example the floating point number 1.0 is a floating point number. 1.22, 2.68, that is also a floating point number. Here 3.12, that is also a floating point number. Here there are floating point numbers here. Here for example another floating point number here is a -1. Here sometimes you are writing like this, so 0.5 or 0.52. Here it is also a floating point number. Here in this way you have a different floating point numbers you are considering. Here another important one here, the minus floating point number you also representing the minus 123. For example the minus 1.23 is also a one type of floating point number here. And then other important information here is a Julia. In Julia allows a floating point number e exponential value. Here also you are considering the exponential value of floating point here. That's value infinite value, some values here. And then other important one here is a, that means in this way you will allow the floating point numbers here. Here thus another important point in this consider, in this case here is a literal 32. That means if it comes to literals, how can you represent the literal value here? That means literal 32 bit values are 64 bit values here. That means the literals 32 bit values can be entered, writing an f in place of e. Here e in the sense for this 64 bit. Here for example f in the sense 32 bit values. Here for example take this one. Here here, for example, you're writing E here. Our system is 64 bit. Here, if you want to write F, instead of writing a E, I am writing the F here. F means here 64 bit system. So for the 64 bit system, the values here you consider as a F. Here, that means 0 point F. In this way, you will calculating the literal values here. Here That is a way of representing the literals. For example, another literal for the f here, for example 225 point minus 3 here. Then if it is the type of system, I'm going to represent the value or type of the system. That means you have a result 0.5 f naught. Here I want to know about the answer here. What is the answer in this case here? The type of the answer here, system is the integer 64 or 32 bits. How can you know it is a float 32 bit system? Here the value here is a float 32. That means E indicates the 64 bit. Float 64. For example, take that one. For that one answer, that means here also you will take a calculate the answer 32 bit. Our system is a 64 bit system. No problem. Here in this way you will calculate the values here. Here the values can be converted to 32 bit easily. Here any type of value, any type of, that means simple values maybe. Here the little another important point here is a, the another important point in this case, the values can be converted float 32 easily. Here how can you converting the float 32 values here? What are the way converting the float 32 values? Here you can converting easily. The, for example, you have a float system. Here you have a, for example, you have a float 32. Float 32 is a function. By using that function, any type of 64 floating number converted into 32 bit system. Here, for example, execute this one. Here is value. Here I want to know about the whether it is a 64 into float 32 or 64. Then you required answer. Here the answer, the type of the answer here. Here what is the type of the answer in this case? That means the current type of the answer it will represent. The type of the answer is a float 32. For example, if I write a, if I write like this. Here what is the value here? For example, minus 1.5. 1.5 is a one type of system. That means what is an answer in this case here? The answer in this case 64 bit. The type of the answer here is 64. Here instead of 64, here uh, float uh, float 32. Here if you write the float 32 of x, float 32 of minus 1.5, that answer is a float 32. That's a way of representing the answer here. That is a the float 32 answer here. Here another important one here is a hexadecimal floating point. The hexadecimal here, the hexadecimal floating point letters are valid, and but only float 64 values with p precision base 2 exponent. Here that means hexadecimal values. How can you represent here? P, that means you required a p here, p, and then the float 64 values, 64 value, p precision and base 2. Base 2 in the sense zeros and ones. Here that values are represented in a base 2 format. That is a representative. For example, if you take the a simple example here, the hexadecimal floating point literal. Here for the hexadecimal floating point literals are, these are all hexadecimal floating point literals. Here this value 0 into 1. Here another example, that is a 1. Another example, 1 point some. Here that value how can you represent here? P. Here this value here is a represented as a 12. P3. Here the floating point. Here for example 0 into base 3. Here in this case also I am representing the 0 into 4 3, 0.23. Here what is the type of the floating point number here? Here if you want to type here, you have a function is there. Here what is the function here? The function here is a type of the answer 64. The type of the answer in this case here is a 64. In this way you will calculating that value. And then the next important one here is a, the floating point numbers have the two zeros. Here another important two zeros. here one thing here I'm telling you. Here floating point numbers, two zeros, positive 0, negative 0. Here we have a positive 0, the negative 0 is there. They are equal to each other but have different binary representation, as they can see in a bit bit string function. That means that those values are, you can string in a bit string function here. Here this type of one of the important things here is a the minus floating point number equal to plus floating point number. How can you represent in that information? That means the minus floating point number, sometimes you have the plus floating point number, sometimes you have here those values. How can you represent in the those values here? For example, here 0 equal to minus 0.0, is it true or false? Yes, it's maybe a true for the floating point numbers here. Here for the floating point number, always minus value plus value 0 here. Here I want to know about the bit string function. There is a bit string function. What is the necessity of bit string function? How many bits it will stores the this value, how many bits it will stores here. If it comes to the bit string function, here for example, if it comes to the bit string function, bit string of 0, here what are the values for this one? How many? That means 64 bits. For example, bit string of 35.0, 35.0, how many bits? How can you store these values? 35.0. That means in this way 1000, and then here comes to the minus 0 function. Here comes to the minus 0 function. Here what is the minus 0.0 for this one? So what is the value? That's why both are similar, whether it is a similar case or not. Here it's having the 0 bit string. The bit string stores the values like this. Minus 1, here 1 is there, even though both numbers are equal. The bit string, the number, the what are the bits in a floating point number, that is represented by with the help of bit string function. Here another important function in this case here is a, here the bit string function over. The next important one, the integer, a special floating point values are there. A special floating point values. Here how can you represent the special floating point values here? The sometimes the special floating point number is a int inf 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 and nan inf 16. For example, it is a 64-bit number. Here for the 63-bit number, for example, if you take the 60 for the special floating point values, here it is a 16-bit number, INF 16. Here float 32, INF 32. Float 64, INF only. For float 64, you are considering the INF value. Here those are all different. For example, for representing the INF representation, and then NAN. Here, what is the NaN here? The value not equal to any floating value. Here that indicates that value automatically not equal to. Here that is a special floating point numbers here. Here for example, here another important one here. If you take the, for example, take this one, execute this one. Here its value here consider as a 0. Here consider as a 0 here. Here why it is a considered as a 0 here? There are there are three special standard floating point values are that that do not correspond to any point on a real number here. It's not any number here. For example, INF in the sense it's not any number. That means any number in the sense it's maybe a infinity, 1 by infinity or something here that indicates the value. That means 1 by 0. sometimes you are having the 1 by 0 here. What is the 1 by 0 value here? Here 1 by 0, I'm taking the 1 by 0. Here what is the 1 by 0 here? Infinitive. Why? Because INF. If it is a 32 bit in the INF, here for example 1 by 0 INF infinitive value. Here another important one here is a for example minus 5 by 0. Here same thing here. Here if it comes to here minus 5 by 0 here. Let us take a simple information minus 5 divided by 0. That value here is also a infinitive. That infinitive is a minus infinitive. Eh, and then that's value here is a minus infinitive. The another example for the minus infinitive value here. For example, minus 0 divided by 0 or some other values here infinitive that gives a infinitive. For example, 0 divided by 0 that gives a infinite value here. And then that means 0 divided by 0. Here let us take a simple example, 0 divided by 0. Here how can you represent the 0 divided by 0? NaN value. Here infinitive having the 1 divided by 0, that is the infinite value. 0.1 divided by 0, that is the infinite value. Minus 5 divided by 0, that is a minus infinite value. And then 0 divided by 0, not a number. Here that's not a number value here. That's a that means you cannot get that value here. That means you have some certain calculations are there. Here what are the calculations here? For example, any number plus 0, any number plus infinitive. Here what is the value? Any number, if you take any number 300, 400, any number plus infinitive, that's value gives as a infinitive. For example, any number minus infinitive. Here the any number, if you take the number here, I am taking a simple number, any number here 500 minus infinitive, this value also a minus infinitive value. Here another important point here is a infinitive plus infinitive is infinitive, infinitive minus infinitive. Here if you take the a special case here, the infinitive plus infinitive is a infinitive. Here for example, infinitive plus infinitive, infinitive minus infinitive, not a number. For example, same infinitive plus infinitive, you will take the infinitive plus infinitive. Hmm. Okay, infinitive plus infinitive plus, I'm taking only plus here. Here I'm taking plus here. What is the value? And that's the value infinitive. You will identify the difference here. Infinitive minus infinitive, that gives a some value here. Infinitive into 0. Here 0 into infinitive, not a number. Infinitive divided by infinitive. Here infinitive divided by infinitive. Here also a not a number here. Infinitive divided by infinitive. Here it's not a number. Infinitive 0 divided by infinitive. Here infinitive. That's also a not a number here. That's indicates the 0. 0 divided by 0. Okay, it's maybe 0 point. Let us take a 0 point or something, 0.1 or 0.2. Like that you are having these different type of the function here. Here another important one here is a type minimum and type maximum values. Here another important two functions here you are considering here. What are the two functions here? Type minimum and type maximum functions are applied to floating point types here. Type minimum, type maximum, here these are all two different functions. You will apply the for the float value. Here what are the type minimum and type maximum values here? Here I am taking the type minimum. Let us take a simple example. Type minimum of float 16, type maximum of float 16. It gives a some certain kind of numbers. Here what are the numbers here for type minimum of 16? Which let us take some time. Yeah, minus infinitive, inf 16, inf 17. Here this is a, and then type minimum. Similarly, 64-bit floating point number. What is the type minimum and type maximum for the floating point number here? type minimum, type maximum floating point number. In this case, for the numbers here, minus infinitive and plus infinitive. Here, next very important concept in this case here is a another important one, the mission epsilon. Here, what is the mission epsilon here? The mission epsilon here, Julia provides a epsilon which gives a distance between 1.0 and the next larger representable floating point value here. It's epsilon distance. It representing the distance value here. For example, epsilon 32, which gives the distance between a 1.0 and next larger, the next larger representable floating point number. Here, for example, I am taking the simple number here, the distance here epsilon. Here, what is the number here? 32-bit number minus some, for example, epsilon of esp of 2.1. Next, and that means floating point numbers required. Yeah, that's gives epsilon not defined here, not defined error underflow stack flow. And then another important one here, the epsilon of, that means this epsilon function always used to distance, identifying the distance. Yeah, for example, epsilon floating here. Okay, I understood this one. Okay, epsilon floating, that's use a certain value. The next floating point number. Here, another important one here, simple epsilon function, same as the float 64-bit function. Here, the same as the above function here, it's a simple float 16 by because I am using the 64-bit system. This is a some representation about the Julia here. And then another important one here is a, that means epsilon you are using a not a single number. Here previously I typed the number here, that gives some error. That means for the epsilon 1.0, 1.0, what is the next integer value? The next value here I'm considering. Here it's a 64-bit number. It's a next value here, this value. And then 1000 point. Here it is a, what is the 1000 point for the 1000 point here? What is the next value? Here, what is the next value here? I'm considering this value. In this way, you will identify the different numbers as well as the integer. Here epsilon, this is a epsilon representation. And then another important one, epsilon yields the some certain value here. Here, that's called here something about the machine epsilon here. And then next important one, Julia provides a next float and previous float values. Here next float and previous float. Here the next float as well as the previous float representation here. Here it also provides the next float and previous float function, which returns the next largest and smallest representation now floating point numbers here. For example, we have a number x is there. That means I want to calculate in the x value. For example, next floating point number. For example, take more cells. I'm taking the more cells here. Here, let us take simple example. Here, for example, this is a floating point number. The number consists of 25 f naught, and then for the what is the next floating point number for this number? Here, what is the next floating point number? Here, for example, it is a for number. Here, this particular number, the next floating point number is a 25,0,0,0,1 f naught. That, and then this way, next floating point number, and then you may calculate the previous floating point number also. Here, this is a the previous floating point number. What is the previous before floating point number for that x value? Here, this is a previous 1.24999 f naught. 0.2449 f naught. In this way, we will identify the next floating point number and then previous floating point number. I want to know the bit string, the length of this string here. Here, how can you calculate the length of this string for the previous number? That means so you may apply the previous number bit string value also. Here, what is the value here? Bit string of previous floating point number. Here, what is the previous floating point number? Yeah, for that one, I'm telling you, take a more bits here. Here, previous floating point number is this one. This represented as a this value, the above value represented as a previous floating point number. This one, the previous, for example, copy this one and then bit string of previous floating point number of x. The previous floating point number of x here is a this value, and then this value calculate bit string. The length of the string here, how many here? The result same. Here the previous result, this result same here. Here this previous floating point number, that value you are considered here. That is a in this way you are calculating the next, the previous float and next float values. Yeah, that is a way of representing the previous float value as well as the next float values here. And then another important one is arbitrary precision arithmetic, bit int bit float. Here you have a two types of bit integer and floating point numbers are there. Here, okay, bit arbitrary arithmetic. Here you have a two types of bit integer and bit float, bit float numbers. What is the necessity of these numbers here? That means bit string, not only that one here, bit string number also is there here. Here, what is the necessity of bit integer and floating point number in this case? Here, bit integer and bit float types are available in a Julia for arithmetic precision integer and floating point number respectively. Here, for that one, you are using the bit integer and bit floating point number here. Not only that one here, string literal at the rate bit string or parts can be used to construct them from the abstract string here. That means you have a bit string, bit integer. Let us take a simple example for the bit integer value. The bit integer value here, how can you get the bit integer value here? Take a, it takes a long time here. The bit integer type of maximum 64. The type of maximum 64 plus 1. This value here plus 1 here. In this way, you will have the numbers as well as the integers here. And then the next topic here is integer. That means not only that one here, you have a certain kind of information related to the integer as well as the float. The next topic you will discuss about mathematical operation and elementary functions. I can stop here.